Hello friends, we're in the middle of talking about solving quadratic functions. We've talked about solving quadratic functions by square root. This last section we talked about when quadratic is in factored form, I can use the zero product property because when I have two different factors multiplied together equaling 0, I could set each of those factors equal to 0 to solve for x. So now in this lesson we're just going to kind of continue that. The last video, I gave all the problems to you in factored form already. They looked like this. Maybe I had like x minus 2 times x plus 6 equals 0, and you had to solve for x. And we talked about how we can do that, because since when both of these are multiplied together equaling 0, either one or both of these factors has to be equal to 0. So I set them equal to 0 and solved for x, and those were my solutions. Today, I'm not going to give them to you in standard form. I'm not going to give them to you in factored form. I'm going to give the quadratics to you in standard form, and you have to take the extra step and factor them. So notice here are all the objectives for today. I want you to be able to write a quadratic in standard form and identify a, b, and c. I want you to be able to find and factor out the greatest common factor of a quadratic. I want you to be able to identify a times c and b and find two numbers that multiply to make AC and add up to b. So I'm going to pause there. Notice all three of those are things that you have already learned. Those were all the objectives associated with Unit 9, factoring quadratic expressions. So all of those you should know how to do. If you don't know how to do those things, I'm going to whiz through them in this lesson. It might be helpful to go back to some of the Unit 9 lessons or zoom in with me and ask me questions, because that's going to come in real handy. The last new objective that I want you to be able to do, the last thing I want you to be able to do is find the solutions or zeros of a quadratic. This is supposed to say of. The zeros or solutions of a quadratic once it is in standard form. And that is the objective we had in the last lesson. So really all of these objectives aren't new. We're just kind of putting them all together. So let's get started. Again, we spent all of Unit 9 talking about factoring quadratics. We're just going to add the one extra step here. In standard form, quadratic equations must equal 0. So the factored form will also equal 0. For the factored form to equal 0, one of the factored terms must equal 0. This is using the zero product property. This is in your guided notes. This is what we talked about in the last lesson. If I have something in factored form like I just put on the previous page, if I have something like this that's equal to 0, one of these factors or both of them has to be equal to 0. If I were to write a quadratic in standard form, like x squared plus 3x plus 7 or something, same thing. If I gave you this, I'd still say, okay, I need you to solve for x. I need you to find the zeros. I need you to find the solutions. But it's much harder to do in this form. So what we're going to do in this lesson, we're going to factor a quadratic expression like this, once it's set equal to 0, and then solve using the zero product property. Let's give you an example. So consider the quadratic function x squared minus 5x plus 6 equals 0. In Unit 9, we were working with expressions like this, just x squared minus 5x plus 6, and we learned how to factor those, and we're going to factor them here. The only thing I'm adding here is I need it set equal to 0, because that's what the zero product property states. I need to have it equal to 0. So this is standard form, x squared minus 5x plus 6, ax squared plus bx plus c. Now I'm just adding the equals to 0. So I give you the factored form here, but let's review a little bit how we find the factored form of a quadratic expression. I need to multiply a and c together. This is 1, this is 6. 1 times 6 is 6. I need to find two numbers that multiply to make 6 and add up to negative 5. So I have 1 and 6 and 2 and 3. And I have negative 1 and negative 6 and negative 2 and negative 3. I need to find those two factors that add up to negative 5. Well, negative 2 plus negative 3 is negative 5, so those are my two numbers. X minus 2 and x minus 3. A is 1, so I divide by 1 here, which is kind of redundant. I can just leave those off. And I'm left with my factored form being x minus 2 times x minus 3 equals 0. So far we've used our knowledge from Unit 9, factoring quadratics. And again, if you're hazy on that or if you didn't fully understand that concept before, chat with me. Let's talk. So if this is the factored form and I'm wanting to solve for 0, or solve for x, find my zeros, I'm going to use the tools that I have from the last lesson. So as a result, if I have x minus 2 times x minus 3, one of those factors or both of them has to be equal to 0. So either x minus 2 has to be equal to 0 or x minus 3 has to be equal to 0. Because again, like the lady in Hidden Figures told us, the mathematician lady, if the product of two factors is equal to 0, common sense that one of those factors has to be 0 to start with. So if x minus 2 is equal to 0 or x minus 3 is equal to 0, and I add 2 on both sides or add 3 on both sides, I end up getting x equals 2 or x equals 3. If you remember from the very first video, every quadratic will have two solutions. In this case, they are 2 and 3. So that's what we're doing in this lesson. There's really not any terribly new information. We're taking what we learned in Unit 9, factoring quadratic expressions, setting it equal to 0, and using the zero product property. Okay, let's do some examples. So for example, factor the following quadratics and then find the solutions. So right now I have 2x squared minus 8 equals 6x. But I need these quadratic expressions to be in this form. Ax squared plus bx plus c equals 0. I need everything on one side of the equation and then 0 on the other side of the equation. Okay? And I need a to be positive. That's another thing, is I need a to be positive. So here I have 2x squared minus 8 equals 6x. Well, I don't want 6x over here. I want 6x over here. So how do I get rid of a positive 6x? I subtract 6x on both sides and get 2x squared minus 6x minus 8 equals 0. Okay, now it looks like this. Next step is I need to factor this quadratic expression. Well, if we're reflecting back to Unit 9, let's review the steps in our head. First step of factoring a quadratic is I need to find a greatest common factor. Is there a greatest common factor between all three of these terms? Yes, there is. It's a 2. If I take a 2 out of each of these terms, I'm left with x squared minus 3x minus 4 equals 0. So now I have x squared minus 3x minus 4. That's my remaining quadratic. I need to factor that. So now I have a is 1. So this is a, b, and c. I need to multiply a and c together. 1 times negative 4 is negative 4. I need to find two numbers that multiply to make negative 4 and add up to negative 3. Those numbers are going to be negative 4 and positive 1. Negative 4 times positive 1 is negative 4. Negative 4 plus positive 1 is negative 3, which is what I needed to add to. Okay, so my magic numbers are negative 4 and positive 1. There's no a value that I need to divide by, just 1, so that's it. I'm done. The factored version of x squared minus 3x minus 4 is x minus 4 times x plus 1. And I have this 2 out in front. So now my next step after I've factored that quadratic expression is now I'm setting it equal to 0. It's equal to 0. So if this whole expression, all these things being multiplied together, is equal to 0, common sense says that one of these terms, or both of them, has to be equal to 0. So x minus 4 has to be equal to 0, or x plus 1 has to be equal to 0. So then if I solve for x, I'm going to add 4 on both sides, or subtract 1 on both sides, and I'm going to get x equals 4, and x equals negative 1. Those are my solutions. And if I plug 4 and 1 back in here, 4 and negative 1, let's double check that we actually get the right equation. So 2 times 4 squared minus 8 equals 6 times 4. Is that accurate? Well, 4 squared is 16, times 2 is 32, minus 8 is 24, and then 6 times 4 is 24. Good, so that's correct. Let's test out negative 1. So if I put negative 1 in here, Negative 1 squared, negative times a negative is a positive 1, times 2 is 2. Minus 8 is negative 6. 6 times negative 1 is negative 6. So indeed, I can check that I factored correctly. I did everything right. The solutions, or my zeros, for this equation are x equals 4 and x equals negative 1. Okay, this is another example that you can do. I'm going to skip on to do another example. Okay, let's do a couple of these. So first, I need to get my quadratic into this form right here. ax squared plus bx plus c equals 0. So here I'm going to go ahead and subtract 18x on both sides and get 2x squared minus 18x plus 36 equals 0. So I need to factor this quadratic, and I'm going to start doing that by taking out a greatest common factor. My greatest common factor in this quadratic is 2. So if I take a 2 out of all three of these terms, I'm going to be left with x squared minus 9x plus 18. Just like that. Equals 0. Okay, now I need to factor this quadratic. A, B, and C. If I multiply A and C together, I get 18. You find two numbers that multiply to 18 and add up to negative 9. So you can list all the factors. I'm going to give them to you real quick. They're going to be negative 6 and negative 3. Negative 6 times negative 3 is a positive 18. Negative 6 plus negative 3 is negative 9. So I'm left with 2 times x minus 6 times x minus 3. My a term is 1, so when I divide by 1, those fractions are kind of redundant. So I have 2 times x minus 6 times x minus 3 equals 0. Well, common sense says that if I'm multiplying these two terms together and they equal 0, one or both of them must be equal to 0. So x minus 6 has to be equal to 0, or x minus 3 has to be equal to 0. So I'm going to add 6 on both sides and get x equals 6. I'm going to add 3 to both sides and get x equals 3. Those are my two zeros, or my two solutions, and you can double check that back in the equation to make sure you actually get those two sides equaling each other. Let's do this one. X squared plus 2x equals negative 1. First, I need to put it in this form. I need to set it all equal to 0. So I'm going to add 1 on both sides and get x squared plus 2x plus 1 equals 0. Okay, now I have a, b, and c. There's not a greatest common factor, so a times c is 1. I'm going to erase this for a moment. A times c is 1, so I need to find two numbers that multiply to make 1 and add up to 2. Well, there's only two sets of numbers that multiply to make 1. 1 times 1, or negative 1 times negative 1. Well, good thing 1 plus 1 is equal to 2. So I have x plus 1, x plus 1, because they're both positive 1s. And since a is 1, this can't reduce anymore. So x plus 1 times x plus 1 is equal to 0. So I need to set both of these terms equal to 0, because at least one of them needs to equal to 0. X plus 1 equals 0. When I subtract 1 on both sides, I get x equals negative 1 and x equals negative 1. Huh! I get the same solution twice. If you remember back to the first concept, the first lesson we discussed in this unit, I mentioned that there are three possibilities. You can either get two real answers, two complex answers, or one answer or one solution repeated. Negative 1 and negative 1. Here is a case of that. So if I put negative 1 back in here for x, I will indeed get this response. Okay, let's do one more. We'll do one more example if you want to do some of these other examples. And again, I'm just going over examples for repetition purposes so you can get this in your brain. Let's do this one right here. It's already in this form, so I can start by factoring. Since it's all set equal to 0, I'm going to factor this quadratic so it's easier to find solutions. I don't have a greatest common factor, so I need to multiply a and c together. 2 times negative 21, which is negative 42. We find two numbers that multiply to make negative 42 and add up to 11. Let's see here. Well, I have 42 and negative 1. I have 21 and negative 2. I have, what's 42 divided by 3? 14 and negative 3. Hey, there it is. 14 times negative 3 is negative 42. 14 plus negative 3 is 11. So those are my two factors. X plus 14 and x minus 3. Now I need to divide each of these terms by a, which is 2. Now I need to reduce those fractions if I can. So 14 divided by 2 is 7. 3 divided by 2 can't simplify. So I'm going to go bottoms up. X plus 7 and 2x minus 3 equals 0. Sorry. Well, notice that I have these two factors being multiplied together. If I have two terms being multiplied together to equal 0, one or both of those terms is going to have to be equal to 0. So I'll do x plus 7 equals 0 and 2x minus 3 equals 0. Here I'm going to subtract 7 on both sides and get x equals negative 7. Here I'm going to add 3 on both sides and I'll get 2x equals 3. I'm going to divide by 2 on both sides and get x equals 3 halves. So my solutions are negative 7 and then a positive 3 halves. And again, if I were to plug those back in here, I would indeed get 0. So those are my solutions. Again, this whole unit is about solving quadratic functions. In the upcoming units, I'm going to talk about, towards the end of this unit and the next unit, we're going to talk about, again, where these are practical, where these are used, kind of the real-world situations that you can model using quadratic functions and how you would solve them. We'll get into that a lot in the graphing part, which we will do in the next unit. So hopefully now you feel even more comfortable with the steps of factoring a quadratic expression and doing that along with using the tools we have and the zero product property to find the solutions or zeros of a quadratic once it is in that factored form. So I hope that was helpful. Please don't hesitate to reach out to me with any questions whatsoever, and I hope you enjoyed that as much as I did.